Alright, in 4.1 we talk about beginning. Basically, Chapter 4 is all about sketching a graph based on all the information we can find using all the techniques that we've learned. Now in 4.1 they talk about being able to find maximum and minimum values. So they talk about two different types of max-mins. Absolute max, absolute min, which is the ultimate highest point and lowest point of your function. Or local max or local min, which is it's a maximum or minimum within a small area around some value. Make a note that a local max or min cannot occur at an endpoint because a max or min requires to have an area around it, whereas an endpoint can be a max or a min. If you're looking at this one, you've got a local min, local max, local min. But this is not only a local min, it's an absolute min. It's the lowest point of the entire function. And this is an absolute max, highest point on the function. Notice this is neither an absolute max or min or local max or min. Trig functions have typically local and absolute maximums, local and absolute minimums over and over and over again. Something like this has a local min and a maximum min, or absolute min, but it has no maximums. This one has neither maximums nor minimums. Notice this one has a minimum value, but it doesn't have a maximum value because that's an open point there. Notice this one has no max and no mins. Its minimum number, there isn't one since it hasn't hold there at 0. And it goes up forever, so it has no maximum. We're going to find out that if we set the first derivative equal to 0, we can have a very good idea as to where we might find maximums and minimums. So we take the first derivative, we find places where the first derivative is either undefined or equals 0, and these are called critical numbers. So if you take the original function and you take its derivative, set it equal to 0, these two are your critical numbers. If you take the first derivative of this guy and set it equal to 0, you find the critical numbers. Typically you're going to have to write your functions as one entire fraction, which takes a little bit of work, but you can do it. The closed interval method, this is to find absolute maximums and minimums of a continuous function on a closed interval. That's important. It must be a continuous function and it has to be a closed interval. You find all the critical numbers, and then you find the values at those critical numbers and the values at the endpoints, and you just pick the largest for the absolute max and pick the smallest for the absolute min. Alright, since this is continuous and it's on a closed interval, we take the derivative, we find out where it equals 0, and we also check the endpoints, and whatever we get a maximum value, that's our absolute max, and our min is our lowest value. This one, if you check it using your calculator, you'll find these two numbers for your maximums and minimums. Alright, but you can take the first derivative, set it equal to 0, and check each of those critical values for values here, as well as the endpoints, and you pick the points that have the largest and smallest values. On this one, they wanted you to find out where the acceleration is at a maximum or a minimum. So you take the derivative of velocity and you take the derivative of acceleration and set it equal to 0, and you get this critical number here. You plug that into the original function as well as the endpoints, and your minimum acceleration is at 23.12 seconds after launch, and it's at a maximum at 126 seconds after launch.